So it's another tip to you guys by considering when we study the flat surface of discontinuity. This is the sort of supplementary knowledge that is associated with the flat surface of discontinuity. The primary or highlight of that I want you to understand on this flat surface of discontinuity things is what? Transmission loss is simply fluid loading impedance divided by partition impedance plus fluid loading impedance. That's it. Depending on physical situation, the partition impedance is changing. Right? In some case, partition impedance is just minus j omega m. In some case, partition impedance has three components. One is a contribution due to mass, one is contribution due to damping, and one is contribution to stiffness. Okay, even if we have plates, partition impedance has two components. One is due to mass contribution. Another one is due to bending rigidity contribution. Simply because everything can be said one blocked frequency plus radiation frequency. We can always decompose the flat surface of physics related with flat surface of discontinuity into two parts. One is blocked frequency, the other one is radiation. And the radiation does depends on partition impedance. And this is our conclusion. Next question is, what if a flat surface of discontinuity has a certain shape? The flat surface of discontinuity we have learned is like a flat impedance mismatch. But I am asking you, what if the surface of discontinuity is no longer flat but have some geometrical shape in space? Now that is the case of radiation, scattering, and so on. So radiation and scattering is just another physics that is related with the flat surface of discontinuity. And the measure that expresses surface of discontinuity is what? That's the impedance. So in other words, the next things we are going to study is, what if there is impedance mismatch in space? Right? What if there is a sphere? What if there is a book in space? What if I shout over here? What would happen? And what you can expect is, when I shout, there is a blocked frequency and plus radiation of this. Right? So it's the same concept, but we just generalize it. In other words, what we are doing is, here is a spring mass dash part, here is a string, and here is another string. And what we will have, how much wave would be transmitted, is totally depends on this impedance mismatch. So radiation, scattering, diffraction can also be understood in terms of the wave phenomena due to impedance mismatch. Now, impedance mismatch is not two-dimensional, it's three-dimensional. Can be shape, can be sphere, can be human head, can be this kind of chair or desk, can be this kind of room. So, I hope you all agree that what we have been studying and what we are going to study is the wave phenomena due to the presence of impedance mismatch in space. And that's what we are going to study from the Thursday. So please read chapter 4, and please read the remaining part of chapter 3, appendixes also, okay? Okay. And we hope Ho Yong-hwa will continue to have good score in. Okay. See you next time.